compound inequalities and or. This video is a continuation of the one where we had the word and in them. So we went through and did those. But now we're going to look at the ones that are grayed out that don't have any words in them. And they basically have three different expressions that are nestled within these inequality signs. And when you solve these inequalities, what you want to do is solve it as if there were two inequalities written just like this with an and inside of it, except we're going to solve only this inequality first and graph it, and then we're going to cover up everything in front of the 9 and solve this inequality next. So basically the 9 plus n is going to be a part of each inequality that we solve. So I'm going to just use my little sticky note here to help me block out that other part, and I'm just going to focus right here on -1 is less than 9 plus n, subtract 9 from each side, and I get n is less than -10. So here's my -10 is less than n. So here's my -10, and it's an open circle because there is no equal sign below it, and -10 has to be less than n. So I always like to choose a value that's easy to work with. 0 is really easy. So if I chose 0 as my n value, would -10 be less than 0? Yes, it would. And if I put 0 in here, I would have 9 plus 0, which is 9, and -1 is less than 9. So my solution for this side of the compound inequality is all rational numbers and irrational numbers that are greater than -10 that go this way. So now what I'm going to do is everything to the left of that 9 I'm going to cover up, and now I'm going to solve this part. So I'm going to have 9 plus n is less than 17, subtract 9 from each side, n is less than 8. So I'm going to find 8. I have an open circle, double check myself there, and n has to be less than 8. So again, I'm going to choose 0. If I put 0 in here, 0 is less than 8, and if I put 0 back in this part of the original inequality, 9 plus 0 is 9, and well, by golly, that is less than 17. So any solution, any numbers that are to the left of this open circle should work for that part of the inequality. So the place that they overlap, I shouldn't say intersect, sorry, is right here. And so this is where n is going to be. Any of these values here could be n, and they should be able to satisfy this whole inequality. So this time let's choose 2. 2 is pretty easy to use. So I'm going to substitute 2 in for n. And if I put 2 in for n, I have 9 plus 2 is 11. And so when I check that out, -1 is less than 11, and that is less than 17. Is that a true statement? It is. So if this value satisfies that, and if I've placed my circles in the correct places on the number line, and I've made sure that the circles are represented correctly, in other words, open or filled in if they need to be filled in. The last step I do is I bring down my the points at which my two circles are, which is -10 and 8, and I bring my n straight down, and I say that -10 is less than n, and n is less than 8, because that is what my graph is showing me. So that is my solution written out. So you can see that they're very much like the compound inequalities when you have the word and in there. This time they don't have the and in there, but they have 3 parts. And as long as this helps me boxing in the middle part so that I know where to cover up. I can cover up the right-hand inequality sign and everything after it and solve that one. And I can block off the left-hand inequality sign and anything to the left and solve this inequality. So let's go ahead and look at number 5. It also does not have the word and in there, but you can see I do have a middle part represented as a fraction. And again, when I write this out, I'm going to write it as 1/2 times p. So it doesn't matter which side you solve first. So to not have my fraction with my variable, I'm going to multiply by the inverse, and the inverse is 2/1. And I'm going to multiply both sides by the inverse. So I'm going to get -6/1, which is just -6, is less than or equal to, these two 2's can cancel, and they can cancel across the p, because remember, these are just multiplication expressions, and multiplication is commutative, so I can do it in any order I want. So this is just going to give me p. So -6 is right here, and it's a filled in circle. -6 is less than p, so p must be to the right, less than or equal to. P must be to the right. So now I'm going to solve the other side, and I'm going to have, again, I'm going to write 1/2 p is less than 0. So I'm going to multiply both sides by 2 so that I can 2/1. So that's going to mean that p is less than 0. So I'm going to come up here and I'm going to find 0. It is not a filled in circle. It is open, and it is going to go to the right. Excuse me, to the left. And I can see that I've got 2 lines right here. So these are my values, should be my values for p that would work for this whole thing. And because I'm dividing by 2 right here, I'm going to choose an even number. So I'm going to choose -4 to check things out. So if I put -4 in for p, I would end up with -4 divided by 2. So this whole quantity here is now -2. So is -3 less than or equal to -2? Yes, it is. Is -2 less than or equal to 0? Yes, it is. So it looks like my values in here would work for this. So I'm going to bring down the numbers associated with the circles. -6, 0. I'm going to bring my p down. and I'm going to put my signs in. Make sure if you have a closed circle, you also bring the line down. Number 10. Here's my middle part in between my two inequality signs. So I'm going to solve the left-hand side first. I need to divide both sides by 7. So -8 is right here, and -8 is less than k. So k is going to be somewhere for this one to the right. And solve the other one. So k is less than -2, and that would be an open circle. Both of these are open circles, and the point at which I have 2 lines is this area right here. So k is going to reside somewhere in here. So let's choose a value. I got kind of messy numbers. I'll just choose -4. So if I input -4 for k, 7 times -4 is -28. -28 plus 6 is going to give me -22. So then when I write the other values that are in this inequality, I can see that -50 is less than this quantity, which is -22, which is less than -8. So I think I've got my graph correct, so now it's time for me to write my final answer. And I'm bringing down my circle numbers that are associated with my circle, and I'm putting in my inequalities. So the only one I have left is number 13. So number 13, here's my middle section, 3p minus 6. So I'm going to solve the left-hand side first. -10 is less than p. Here's -10. That's going to be an open circle. Now I'm going to do the other side. So p is less than -3. Here's -3. And p has to be less than that. So that's going to go to the left. And this one is going to the right. And so right here in the middle is where they overlap. So that is where P is going to reside. So I'm going to bring the numbers down associated with my circles. -10, -3. P goes in the middle, less than, less than. There's my answer. And that is the end.